We need to add or subtract the fractions in this problem. In this case, we're going to be doing a little bit of addition. We have a fraction plus a fraction, and anytime you add or subtract fractions, you do need to have a common denominator. If you take a look at our denominators right now, they are different. We do not have a common denominator. So the first part of this problem, we're going to need to identify what our common denominator is and then work towards getting that in the bottom of both of those fractions. In order for us to do that, we do need to have these denominators in a factored form. So copy down those numerators, and then I'm going to go through and factor those two denominators. In our first fraction, I have an x squared plus 3x minus 4 down here in the bottom. That's in standard form. Nothing in common. I do have three terms, so I'm going to do the add multiply method. I will be able to use the shortcut because we do have an x squared in front. Sorry, we do have a 1 in front of that x squared term. So using the add multiply method, I'm looking for two numbers that add to be 3 and multiply to be negative 4. Those two numbers would be a positive 4 and a negative 1. So using the shortcut, that denominator factors into an x plus 4 times an x minus 1. If you try to factor the denominator of the second fraction, it is not factorable. It doesn't fit any of our rules at all. There is addition there, so I'm going to throw that in parentheses. And then from there, what I want to do is I want to identify what the least common multiple is. When you find a common denominator, really what you are searching for is the least common multiple. So I want to take a look at these denominators and determine what the least common multiple would be. The first thing I see in our factored form is we have an x plus 4 in the bottom of this first fraction. We also have an x plus 4 in the bottom of the other. If the powers are different for those, then we would use the higher power. But this is an x plus 4 to the first power. This is also an x plus 4 to the first power. So x plus 4 to the first power is the highest power. The first fraction has an x minus 1. There's not one in the other one. When that happens, you can just copy that down because that is the highest power of that particular factor. In the bottom of the other fraction, we have that x plus 4, but we've already used the x plus 4s to come up with our common denominator, or our least common multiple, rather. So now I know what our common denominator should be. What we want on the bottom of both of these fractions is an x plus 4 times an x minus 1. So what I'm going to do in this next step, I'm just going to copy these down again, but I'm going to leave a little bit of space here. After each one of those fractions, so that I can get these denominators to be the same. Here's the least common multiple. That's what I want in the bottom of both of these fractions. I do have that in the bottom of the first one, so I actually don't need to change this one at all. But the second fraction, I have the x plus 4 that I need, but what I'm missing, I am missing an x minus 1. So what you do is you multiply the top and the bottom of that fraction by an x minus 1. We're multiplying the top and the bottom because x minus 1 over x minus 1, anything divided by itself is just equal to 1. And we can multiply something by 1 and it won't change the problem. So we're multiplying the second fraction by a very fancy number 1. And now if you look at the denominators on both of these, they are exactly the same. So in my next step, I can write this with just a single fraction. In the bottom of that fraction is going to be our common denominator. This should be an x minus 1 here. And then in the top, we would have an x minus 3, and then we have plus a 2x times an x minus 1. We now have a single fraction, which is what we were going for. Let's see if I can write this right this time. X plus 4 times x minus 1. There we go. And what we want to do is we want to leave this bottom the way that it is. There's no addition or subtraction outside the parentheses, so that's totally fine. But if you look at the top that we have here, I do have some addition outside and some subtraction actually outside of the parentheses. So what we need to do is get rid of all the parentheses in the top. So I'm going to take this 2x that's here, and using the distributive property, I'll multiply that by both of those terms. So the x minus 3 is here, and then the 2x times x would give me a plus 2x squared, and 2x times a negative 1 would be a minus 2x. And then from there, I'm going to want to write this top part in standard form while I simplify that and combine my terms. So the highest power of x there is a 2x squared. That's the only x squared term, so nothing to combine there. I do have some x's I can combine together though. I have an x here and a minus 2x there. So 1x minus 2x, that would be a minus 1x or minus x, and then a minus 3 out on the end. In the bottom, we're not doing anything with those parentheses because there's no addition or subtraction outside of those. So now I have gone through and added or subtracted, but we do want to simplify this also, which means we need to factor the top and the bottom. Bottom's already factored, so we just need to factor the top and determine if we can simplify this at all. To do that, let me do a little scratch work off to the side. I have a 2x squared minus x minus 3. I want to go through and I want to factor that. I can't use the shortcut, so I might need to do a little work off to the side to get this worked out. It is in standard form. There's nothing in common with those terms. So I'm going to go through and do the add multiply method, but I can't use the shortcut. Has to add to be the middle coefficient, which is a negative 1, and multiply to be the lead coefficient times our constant, and 2 times negative 3 is negative 6. If I can't find numbers that fit that, then either I haven't searched hard enough or it's not factorable, but there are two numbers that fit that pattern. They are a negative 3 and a positive 2. So I'm going to take these three terms that we have here, and I'm going to copy the first term down, take this x term up, and break it up using these two values. So a minus 3x plus 2x, copy that last term down again, and then I'm going to go through and do some factoring by grouping. The first two terms have an x in common. The last two terms don't have anything in common, but I need to factor something in front. So it's either going to be a positive or a negative 1. And this first term in the last group, that is a positive. So I'm going to factor a positive 1 out in front on that. I did get matching parentheses, so this does factor. So doing a little work off to the side, I can see that our numerator here, that does factor into a 2x minus 3 times an x plus 1. From here, now that everything is factored and I don't have anything, I don't have any addition or subtraction outside the parentheses, now I could cancel things out top and bottom if I get anything to match there. Nothing matches, so this is our final answer. At the beginning of this problem, We were given the directions add or subtract. We've done that and simplified our answer as far as we can. It also said, identify any x values for which the expression is undefined. So what we need to do in order for that to happen is to come back to this step and take a look at our values here and determine which x values you would have that would cause you to divide by 0. Basically, you can look at the least common multiple and see what would make that equal to 0. So if you were going to get a 0 for this x plus 4, what we would be plugging in there is a negative 4. So you could do x plus 4 equals 0 and then solve. Subtracting 4 on both sides gives you a negative 4. Similarly, you probably can see that 1 is not going to work because that would give us a 0. Or you can set it equal to 0 and then solve. So the two numbers that x cannot be equal to are a negative 4 and a positive 1. So as part of our final answer, x cannot equal a negative 4 or a 1.